Okay, so let's go over some examples. In the next problems, we're going to need to label whether it's an acid, it's a base, and then figure out what the products are going to be. I think the best way to do this is to show you, all right? So as it says here, how do we actually do this? We're going to use context clues from the equation, and we're going to mix that with the content we've talked about this year and in this chapter. So it's kind of like you're going to, figure out what's the acid and the base from everything we've learned this year, all right? So first up, we take a look at this problem here. All right, so the first thing you should ask yourself is, do you see one that is definitely an acid or definitely a base? All right, so if you take a look at them, what do you see there? Yeah, there's an HCl, right? And if you look at that, that starts with an H. Okay, that's a great indicator that that's probably an acid. The one time where you can't really use that is when it's water, right? When it's H2O, you shouldn't start with it with water. You should usually figure out if it's an acid or base from the other thing that it's paired with. All right, so HCl. Great guess that that's an acid. How else do you know that it's an acid? Yeah, exactly. You memorize that it's one of the 7 strong acids, right? It's hydrochloric acid, HCl. So we know that this is definitely going to be an acid. Okay. And like I said before, you know the nomenclature for it. It's hydrochloric acid. And again, it's hydrochloric acid because it's binary, meaning it just has two elements in there. So we use the hydro and the ic. All right, so that's where we get the hydrochloric acid from. Now, if we look at the second thing, this NH3. First off, it may be something you might recognize. You might say, oh, it's ammonia. All right, cool. You might remember from an earlier video, I might have mentioned that it's a base. But even if you don't remember any of that, it's okay because you know that it's a base in this situation, because if this is the acid, the other thing has to be the base. So as long as you can figure out one of them, then you're good. All right. Okay, so let's figure out what the products are. Now, if we go back to the Bronsted-Lowry definition of an acid, we said that it's a proton donor, okay? Which means this acid, this HCl, needs to donate H+, all right? Which means, let's take a look at it. We have HCl, all right? So if we break it apart, it's H+, Cl-. So if it donates H+, what's left over? Yeah, the only thing that's left over is the Cl-. All right, so we have that Cl- there. Now, the next thing that we have is NH3 here. We know that it's a base, right? So what do bases do? They are proton acceptors. So that means that NH3 is going to accept this H+. It's going to come over here. So that's going to make it NH4, but don't forget about the plus. It's going to be NH4 plus there, or we know that's ammonium, all right? So this is what we're going to end up with in this problem here. We'll end up with Cl- and then NH4 plus. All right, good job. Okay, now let's look at this one. Take a minute, pause the video, really pause it, and try this problem. So if you did pause it, great job. If you didn't, that's fine. Make sure you like and subscribe. All right, so let's look at this one. What did you put for the acid here? Now notice they both start with H's, right? So you have H2O, which is water, and then you have this other one, this H2CO3. Now, you shouldn't start with water. You should always look at the other one. And since the other one starts with an H, that's a good indicator that this is an acid. Now, it's not a strong acid because it's not one of the 7 that we memorized. Another hint that it's not a strong acid is the double-headed arrow, right? You have to use this when it's not a strong acid or a strong base. If we go back to the last problem, you can see that it's in there, right? So that was an indication that something here was strong. And then if we remember, HCl is our strong acid. Okay, so now that we know that H2CO3 is our acid, water is going to act like a base in this situation. We could also talk about the nomenclature for this as well. For example, this is a polyatomic ion, right? So it's carbonate, all right? And what does ATE change to? Yeah, exactly. It changes to IC. So this is going to be carbonic acid. So now we need to figure out what the products are going to be. So since this is our acid, it's going to lose an H plus, right? And it's just going to lose one H plus. That's all that's going to happen for the first problem. We're not going to lose them all, okay? So let's take off one of them. This is where things get a little complicated, but if you remove one H plus from this, it's going to be just an HCO3, okay? But we need to think about the charge too. It lost a positive, right? So if it's balanced now and it loses a positive, what's the charge going to be? Yeah, it's going to be -1 because it lost an H plus, right? So that H plus that it lost is going to go to the water. So the H plus is going to go to that water, making it H3O. And don't forget about the positive, all right? So it's H3O plus. So now if we write our products, we're going to have HCO3 minus, and then we're going to have H3O positive. Okay, hopefully that makes sense.